Imagine you're in a massive library with a billion books, and you need to find one specific sentence. A regular computer would have to open every book, read every page, check every line, one at a time. Even the world's fastest supercomputer would take years. But what if a computer could read all the books simultaneously? Not faster, simultaneously. Every book, every page, every word, all at once. This isn't science fiction. This is quantum computing. And in 2025, we're witnessing breakthrough after breakthrough. Google just achieved verifiable quantum advantage. IBM is launching their most powerful chip yet. Princeton engineered qubits that last 3 times longer than ever before. Let me show you why this changes everything. First, let's talk about why we even need quantum computers. Your laptop, your phone, even the most powerful supercomputers on Earth, they all work fundamentally the same way. They use billions of tiny electronic switches called transistors. Each transistor is either on or off, 1 or 0. That's it. This works brilliantly for most things. Watching videos, browsing the web, playing games. Regular computers handle these perfectly. But some problems are just too massive. Simulating how a new drug will interact with every molecule in your body, that requires checking trillions of combinations. Optimizing delivery routes for thousands of packages across hundreds of cities, billions of possible routes. Breaking modern encryption. A regular computer would need to try every possible key. There are more combinations than atoms in the observable universe. For these problems, even checking one possibility per nanosecond would take longer than the age of the universe. We've hit a wall that faster chips can't solve. That's why the quantum computing market is exploding from $3.5 billion this year to over $20 billion by 2030, growing at 42% annually. So how do quantum computers break through this wall? They use the strange, almost magical rules that govern the quantum world, the world of atoms and subatomic particles. In the quantum realm, particles don't follow our everyday rules. A quantum bit or qubit isn't just a 1 or a 0. It can be both, simultaneously. Scientists call this superposition. Think of it like a coin. When a regular coin lands, it's definitely heads or tails. But imagine a coin that's still spinning in the air. In that moment, it's kind of both heads and tails at the same time. That's what a qubit does, except it stays in that spinning state while doing calculations. Here's where it gets wild. 2 qubits can represent 4 states at once. 3 qubits, 8 states. Every time you add 1 qubit, you double the possibilities it can explore simultaneously. Google's new Willow chip has 105 qubits. In theory, that's 2 to the power of 105, more than all the atoms in the known universe. And Willow just proved this isn't just theory. It solved a specific problem in 5 minutes that would take the fastest supercomputer 10 septillion years. That's 10 with 24 zeros. That's longer than the universe has existed 2 trillion times over. But here's the thing. This wasn't about solving a useful problem yet. It was about proving quantum computers can actually do what we thought was impossible. Now, if quantum computers are this powerful, why don't we all have one? Because qubits are extraordinarily fragile. Remember that spinning coin analogy? Imagine trying to keep a coin spinning forever. The tiniest vibration makes it fall. A gust of air, someone walking by, even the Earth's magnetic field. Qubits are like that, but a million times more sensitive. They lose their quantum state, their spinning ability, in about 100 microseconds. That's 1/10,000th of a second. To keep them stable, scientists cool them to near absolute zero. That's minus 273 degrees Celsius, colder than outer space, colder than anywhere natural in the universe. And here's the cruel joke. For 30 years, adding more qubits made the system worse, not better. More qubits meant more errors. It was like trying to build a house of cards in an earthquake. The bigger you built, the faster it collapsed. Quantum error correction was supposed to fix this. The idea is simple. Use multiple physical qubits to create one super reliable logical qubit. Like having backup singers. If one messes up, the others keep the song on track. But historically, the backup singers just added more chaos. Scientists knew there was a theoretical threshold, a point where adding more qubits would reduce errors instead of increasing them, but many thought we were years, maybe decades away from crossing it. Google just proved them along. December 2024 and October 2025, Google announced major breakthroughs with their Willow quantum chip. First, in December 2024, they achieved something quantum scientists had been chasing for 30 years. They crossed the error threshold. For the first time in history, adding more qubits made the system more accurate, not less. The error rate didn't just improve, it was cut in half with every doubling of qubits. Think about what that means. It's like discovering that adding more singers to a choir makes them sing more in tune, not less. It defies what we've seen for 30 years. Then in October 2025, Google dropped another bombshell, the quantum echoes algorithm. This wasn't just fast, it was the first verifiable quantum advantage. The algorithm ran 13,000 times faster than the world's fastest supercomputer, and here's the key. You can actually verify the results by running it on another quantum computer. This is what scientists call practical quantum advantage. It's not just impressive, it's repeatable, it's checkable, and it's real. Google's results were published in Nature and confirmed by independent teams. One researcher called the December 2024 achievement going from the Wright brothers' first flight to proving that jet engines are actually possible. The October 2025 breakthrough? That's like taking the first commercial flight. The race was already on, but Google's back-to-back announcements just proved quantum computing is moving from labs to reality. Google isn't alone in this race, and 2025 has been absolutely explosive. IBM just unveiled their Nighthawk chip in November 2025, 120 qubits with advanced error correction, shipping to users by year-end. They also demonstrated the Loon processor, showing all the components needed for fault-tolerant quantum computing at scale. Princeton engineers achieved a massive breakthrough. They built qubits that stay stable for over 1 millisecond, 3 times longer than the previous record. That might sound tiny, but it's huge in quantum terms. With a 1,000-qubit computer, it could work roughly 1 billion times better. IonQ set a world record with 99.99% two-qubit gate fidelity. Quantinuum launched Helios, claiming it's the most accurate commercial quantum computer available today. And the money, staggering. In just the first 9 months of 2025, quantum companies raised nearly $4 billion, triple all of 2024. Governments worldwide are investing billions. This isn't gradual progress anymore. This is an arms race. But here's the problem. There aren't enough people who know how to build these things. Right now, there's only one qualified quantum computing expert for every 3 job openings. This isn't just academic research anymore. This is becoming a massive industry with countries competing for dominance. The quantum revolution isn't coming, it's already begun. So what does this actually mean for you? Drug discovery could be revolutionized. Right now, developing a new medicine takes over a decade and costs billions because scientists have to test millions of molecular combinations. Quantum computers could simulate these interactions perfectly, testing millions of possibilities simultaneously. New cancer treatments, Alzheimer's drugs, antibiotics, all discovered in months instead of decades. In October 2025, Google used their quantum echoes algorithm to analyze molecular structures. The quantum computer matched traditional results and revealed information not usually available. It's like having a microscope that can see things invisible to current technology. Battery technology? Quantum computers could design batteries that hold 10 times more charge, making electric cars that drive 1,000 miles on one charge. Climate modeling could become accurate enough to predict weather patterns months in advance. McKinsey estimates the economic value could reach up to $850 billion by 2040. But based on 2025's breakthroughs, that timeline might be conservative. Google's VP projects real-world quantum applications within 5 years. Not decades. 5 years. Now, the security challenge. Today's encryption protects your bank account, medical records, and government secrets. A sufficiently powerful quantum computer could break that encryption in hours. The good news is scientists are already developing quantum-safe encryption, and governments are updating their systems right now. The question isn't whether quantum computers will change the world. It's whether we'll be ready when they do. We're standing at the beginning of a new computing era. Just like the 1970s when personal computers were being built in garages, we're watching quantum computers move from university labs to real-world applications. Google's breakthrough proved it's possible. The investments prove it's happening. The talent gap proves it's urgent. Quantum computing will tackle problems that classical computers simply cannot solve. And in doing so, they'll reshape medicine, security, climate science, and technologies we haven't even imagined yet. The quantum future isn't decades away, it's already here. Thanks for watching. If you want to stay updated on computing breakthroughs, subscribe and hit the notification bell.